Okay, it starts already. Just
Okay, we're ready?
Yep.
Alright. Alright, good afternoon, ladies and gentlemen. Today, we're having a presentation for the operating system class. We are team 3. We're going to be presenting the system exec file, as you can see from here. Our team members are Ziad, then Jesse, he's the golden camel there also. There's Nick all the way at the back, and it's me, tauseef. Alrighty, to begin with, I shall be talking about the system call that is going to take place in the system called as file, the system execve. What it does is it does a LEA operation. What is LEA? LEA is the load extended address. What's happening here is the stack pointer is getting displaced by the 32-bit instruction pointer, and that value will be stored inside a register. And then the register value will be pushed into a stack as a literal, and that's why we're using push literal. But hey, notice something. In a MASM, which is from Microsoft, you'll see that the destination is usually first and then the source, but not in this case. Here, the source is here and then the destination. Then we perform the call do exec function, which will be explained to you by Ziad. What happens is after that do exec function is executed, the pointer needs to come back onto the stack. But hey, we already had something over there, so we need to adjust the stack pointer. So what we do is we add the value 4 onto the stack as a literal again to correct the stack pointer, and then we do a return. To call the exec function, this is how we're going to do it. We're going to call it through this method function execve, and we're going to be pulling in the bin/sh, which is the file path, but also the file name, along with the argv pointer and the endv pointer. These are arrays to pointers that points to number of strings and in a user mode. The argv is the argument vector pointer, and endp is the envelope pointer. All right. Next is the definition for the do exec, which is, again, as I said, he's going to do it. Explain it to you. Here, it's declared as an int, where we are calling in instruction pointer, a pointer to an instruction pointer, the pointer to a file name, a pointer to a pointer to the argument vector pointer, and a pointer to a pointer to the envelope pointer. If it's successful, it will return a 0. Otherwise, it will halt on an error.
Do not point a laser pointer to the audience.
Yeah, I'm trying to keep them awake, so they'll fall asleep. Alrighty, and this is the do exec the definition, and this will be this part will be continued by Ziad.
Okay, now we get to the real definition of do exec. We have only one main function that's going to execute the program. And it's going to be calling some other functions. I'm going to only give the big picture of those other small functions because they're not really useful except for returning values to our main function. Okay, now we're declaring some kind of stuff over there. We're declaring the inode, which is of type inode. Inode is actually just a data structure that stores information about the file, like the mode, the type, all that kind of stuff. Then we're declaring buffer head, which is a pointer over there. We're declaring a page. This page, it is an array. It's going to have a maximum of argument pages allowed, which is 32. That's basically the array where we're going to store the envelopes and the arguments. As my friend explained, envelopes are actually arrays, and arrays in the user mode space, and they're of type name equal value. Those are represent the environment where the process is gonna run. Okay, then we're declaring RGC and VC. You guys can guess that from the name. RGC will have the counter, which means how many arguments we have, and VC how many envelopes we have. Then P, I'm gonna talk about it later because it's really important, but you guys can see it better in the code. Then we are declaring the binary section, which is the user mode section where the process is gonna run. Okay, now we have a first if statement. Basically, the whole chunk over here I'm showing is checking permissions on that file. Before we can run the file, we need to check permissions. So we're gonna check over there, the FFF, we're gonna end it logically with the EIP1 to check with the starting place of the user space. The user space address starts at 000F and hexadecimal. So now we wanna make sure that the EIP, which is the instruction pointer, does not point to something in the kernel, because all the processes we want to run should be in user mode. So that's why we call the panic and say, hey, the process was called from the supervisor mode. Then the easy for loop over there is just going through all the pages that I told you before. We're going to be storing arguments and envelopes in them, the 32 pages. It's going to go through all of them and store a 0. This way we don't keep any page from previous processes and stuff. Okay, over here, there is a trick over here. If you notice, there is only one equal, not two. So this if statement is not checking actually a condition or something. It's just assigning the function called name I. What name I is doing, you give it a file name, it will give you the information about that file name, which means the inode, as I explained before. So the inode is going to get assigned to our variable inode. Then we check it. If it was 0, which means not 0 equal 1, then this if statement will run. If it's 0, it means we could not get that inode. We return an error right there. Over here, there is another if statement, of course, also about permissions and kind of stuff. This is not a function, this is actually just a macro. We send the mode. I'm going to talk about the mode a lot later, but this is a mode for now. You need to know that it's actually 16 bits and it's stored